Hey, welcome everybody. Here we are.
Here we are.
Here we are. We're live. We got.
Is this how you guys start a live?
Yeah, this is
days of live TV. All right. Welcome everybody.
That's
now
right.
It's just like, what's up? We're here. I'm
like
alive.
that.
Are you guys alive?
Yeah, we're here again. This is the opposite of overkill, Bill. This is underkill, Bill.
Yes, it's underkill, Bill.
There he is.
Wait a minute. What was that?
No.
That was Mr. Bill. So, hey, I'm going to introduce Corbett because I asked ChatGPT, who's Corbett Lunsford? And I want to.
Oh, wait a minute. So ChatGPT is going to introduce Corbett. You're just going to read it to us.
I'm going to read it.
All right.
Corbett's a well-known figure in the field of home performance, building science, and energy efficiency. He is particularly recognized for his work in educating homeowners, builders, and contractors on how to improve the performance of buildings, focusing on energy efficiency, comfort, health, and durability. He's the co-founder of the Building Performance Workshop, an educational organization focused on training building professionals on high-performance building techniques and diagnostics. He also co-hosts the Home Diagnosis TV show, the first show on U.S. public television dedicated to the science of homes. The show aims to teach viewers about how homes work as systems with a focus on the importance of diagnostic and performance testing. I could go on, but that's pretty good.
Good job, AI.
So for our viewers who aren't familiar, this is Corbett. Welcome,
Hello,
Corbett.
Thank you.
And
by the way, if I may introduce these guys, Bill is, I like Eric too, but Bill and I go way back. He slept at my parents' house along with Joe Medosh. And if you don't know who that is, look him up later on.
But not in the same room even.
I want to see what ChatGPT says about Joe Medosh.
I wasn't going to say anything there, but I was going to ask.
That's right. But and then also you guys were one of the founding sponsors of that television show. So thank you.
Absolutely.
For your work making that possible.
Cool. So we you and I chatted, and we were just catching up a few weeks ago, and you presented this concept of the 5 factors of ventilation. And I talked to Eric, and I said, this sounds pretty interesting. Sounds like something we want to share with our audience and figure out what this really means and why you've come to the point where you've identified 5 things.
So HVAC, right? Heating, ventilation, and air conditioning. And air conditioning is one thing, we think. Really, it's 2 things. If you know, you know. Heating is one thing, and heating and AC are manual J, and then manual S and manual D. And I do that kind of stuff. But then I found that I kept on getting these clients who were like, "I'd like to hire you for my HVAC design," and then we would get to the end, and they'd be like, "Okay, so this is going to work, right?" And I'm like, "No. This is not going to work because you don't have all these other things. Like, this is a tiny system." And unfortunately, you kind of have to you got to tell the story and you got to get all the way to the end and then be like, that doesn't work. Right. And then you realize this ending is not satisfying to me. I need these other things. And so what we kind of came to is, and I'm a dummy, I come from music. So I have to find ways to explain this to myself so that when I am working with somebody on a really complicated, like what I did today was I saw 5 different people in different parts of the country on Zoom for an hour, and we tried to solve their problem or make a plan for them for their new construction in 1 hour. And I always have to get up to speed, figure out what their needs are, figure out what their health problems are, figure out what they want out of their house, what's going on, what part of their house is renovated, what part is new construction, and then figure out how to make a plan for them out of this. And what we came to is everybody needs to at least think about all 5 of these factors, and none of them are included necessarily in that manual J, manual S, and manual D process. Circulation. This is a classic problem when you've got high performance homes because you're going to build like Bill's house, like my house. Eric, do you have a high performance house? You got to get one, man.
It's getting there.
Yeah, it really. And for anybody else who's watching, who's a professional, there is no way. Part of what I do is spray Kool-Aid all over the place. I like to say in a joking way, which is kind of not a joke, welcome to the cult when people come into the home performance space. Because once you're here, you can't unknow what you know. And what we know will not make anyone happy, by the way, just to warn you before you go into the rabbit hole. But once you are in there, then you need to start figuring out that when you make a home really tight and really well insulated, and when I say really, I mean like substantially, not even incredibly. You have a much smaller HVAC system, and that smaller HVAC system doesn't move as much air. And an HVAC guy is going to step into this. And Eric, were you an HVAC technician, or have you just worked in kind of education for?
No, I started out 20 years ago. It took my first step into the HVAC world. For me, I jumped in immediately to a company that was an NCI company.
Nice.
And big time NCI. We did air balancing. We did tons of stuff. I did immediately stepped into doing combustion analysis and all this other stuff that when I look back now, it was like, that was a little different path than a lot of people took into the industry.
100%. So I think that with typical HVAC guys, not necessarily somebody like Eric, because probably to Eric, it's not two things, it's a whole bunch of things. But to any standard HVAC guy or woman, they're going to think about two things, but they're going to call it one thing because they only have one tool, which is the hammer, which is the piece of equipment that they're using. They're worried about heating, cooling, and also air mixing and circulation. But when they look at a great big room that has no outside exposure at all, they're going to be like, we need more vents in here. And by the way, let me just tell you that I am single dadding it this weekend. My parents are trapped in Florida. They were going to come up here and be with me to watch my kids when we scheduled this. So this is my little boy. He's going to be a little, it's going to be a little chaotic.
So this show maybe may convert to Corbett and chaos with kiddos.
That's right. So I can explain this with him. So essentially, when you see a great big room, you're going to be like, we need more vents in here. They are not saying we need more heating and cooling in here, because in fact, if you look at the manual J, you don't. But they're right. You do need more vents in there for circulation. And that's why I have things like this running in my house all the time. That is locked on low speed, upward direction, 24/7. To turn off any ceiling fans in my house, you actually have to have a screwdriver with you, because I bought these little pieces of plastic that I once saved an entire multifamily building from itself. With these little pieces of plastic, you can get at Ace. They're like, you screw them onto the light switch and it holds the light switch in an upward position, or downward, I guess, if you wanted to. But anyway, so those are a part of my HVAC system, because moving air around used to be the job of a big fat piece of equipment that now we don't have in homes anymore. And so that when they say this piece of equipment is too small, they don't necessarily mean it doesn't create enough heat or cool. They might mean it doesn't move enough air, which they're right about. So that's the first factor. Second thing is capture and filtration. And filtration, Bill's got a giant filter behind him / beside him that I'm very interested in. This whoosh filter. And we'll talk more about that on our channel soon. But basically, filtration is a form of capture, right? So you're grabbing things out of the air. And if you imagine an aquarium, I've never had an aquarium in my own home. I had hermit crabs and they all died, and they stink terribly when they do. But I was not a responsible homeowner back then. But then what you are doing is filtering the water in your aquarium. And if you've ever had an aquarium and you accidentally turned off the pump for 6 hours, the thing turns green. So we can imagine our homes the same way. You just want to keep that water filtering through that pump all the time and grabbing all the little crud that's floating around with skin flakes, all the stuff that kids, are putting out into the air. And so filtration is one thing. You want to keep that air moving. Often I'm recommending that people keep their air handler on 24/7 as a result. Is this super distracting, by the way?
No.
All right.
I'm fine with it.
Real life, man.
Yeah.
So, and then capture is grabbing the pollution at the sources where we're creating it. And by the way, I had a client today I was like, how many kids you guys got? And they were like, well, we have 4 kids, and our sister lives with us and she has 2 kids, and my dad lives with us. And And so then I was looking at their plan, going through, and we're marking where the ERV extract points and the bathrooms need to be, blah, 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 because it's going to incinerate a house and it needs balanced ventilation. And I was like, what is this? And we're looking at this room that was totally inside the enclosure, and it had 2 big boxes in it. And they were like, oh, that's a double shower room, because they've got so many girls in their house that they need to build in a room that's a shower room that has 2 totally separate showers, like a gym shower room, basically.
Locker room, yeah.
So anyway, it's that kind of a thing where you just don't want that wandering around the house. You always grab the pollution where it's created. And that goes for the kitchen too. So generally, every home needs to have capture. Every home needs to have some kind of filtration, even if it's just to protect the equipment. And every home needs circulation. When we get to the next thing, humidity control, a shocking amount of homes actually do need this, but you wouldn't know because we are very adaptable and floppy in our home occupying habits. So humidity control is factor number 3. And by the way, I'm going to blast this thing up on
Sure.
screen here. So I'm going to share my screen.
Go for it.
Yeah.
Hi, Ryan Hughes. Hi, Mike Ficacci. Hi, Tom Leck.
Oh, you know what? This thing is so crazy. Here, what is this?
Just saying hi to our.
No, I can't do anything.
I'm sorry, guys. This is so crazy. What is this?
Hasn't given me anything to do with yet.
No, it's not. Whatever. I
do have the slide you gave me, or
no, it won't show that. It's fine. So circulation, capture, filtration, humidity control. I've got videos about this. I've got it all. It's all over the internet. Humidity control is adding humidity in the wintertime, subtracting humidity in the summertime. In Phoenix, you need a dehumidifier because and you won't know this if you do a manual J, S, and D, because the manual J is about design temperatures for the temperature design. A design is like the peak load, right? So design temperature in Phoenix is 110 degrees Fahrenheit. But that is not, and nor is it anywhere in the country, and probably in the world, the same as the humidity design. In Phoenix, it happens that the humidity design temperature is 80 degrees. That's in monsoon season. So when it's 80 degrees, your air conditioner is not running very hard if it's designed for 110. And you have this big influx of air from outside that's very humid, because when you're building airtight, and we're talking about airtight, like substantially airtight, like 3 ACH is kind of your future proofing, 1.5 ACH 50. This is blower door metrics, by the way. If you don't know what a blower door is, check that out. But 1.5 is generally kind of rule of thumb where we start worrying about pressure effects from any one-way fans. So in a home like Bill's and a home like mine, we cannot have even a single 50 CFM bath fan. We cannot have a dryer that vents outside because it starts really screwing up the pressures in the house. Right, Bill? Yep. Do you have a heat pump dryer?
Yes.
And I get clients every day who is like, hey, can't we do some makeup air thing? Because I love my gas dryer for some reason. I don't know why, but people are like,
cooked clothes.
It's like, yeah, I don't get it, but I think it's myth. It's the same as the 500 square feet per ton. You guys should listen to yourselves sometime when you're like, oh, but I love what is like, are you sure you love that? It's like, I want my bedroom to be 65 degrees is my personal pet peeve. You really don't. You are super uncomfortable in your bedroom because there's radiant heat happening that you're not aware of. And so the air temperature is 70 degrees, but you need to make it say 65 so that the temperatures become 70. And that's really what's happening. So you won't know that until you live in a house. So to blast through these, go ahead.
When you lay on a bed with a giant oven over top of you and it's radiating heat on down to you, it's kind of like laying out in the middle of the yard on a sunshiny day.
Yep.
But with exactly 70-degree temperatures.
So on the thermostat, then the thermostat on the wall will still say 70. Because the air temperature is 70. That's not reading. It's called mean radiant temperature. Which, by the way, Bill, do you guys have a mean radiant thermometer that you like, that you deal?
We've got a couple of them, but we don't sell a lot of them. I got I think X-Tech has one.
X-Tech, yeah.
And maybe FLIR has one as well.
There's one that data logs. I can't remember what brand it is, but I was interested in that one because it data logged. I thought that would be a cool idea.
We can also get one through Testo.
Okay, cool.
Theirs will data log, I know, because it data logs for a lot of the European standards, which
part of a system of probes. Yeah.
And these are the kinds of things, for those of the people who are watching, that's like really useful to know what actually is happening, because there's people's behavior and what people say and what people say they want and what people say they've experienced and what they've actually experienced. But the language messes it up. Like there's a lost in translation thing. So quickly, the last two elements are dilution air, which most people think is the whole V in ventilation. It's ASHRAE 62.2. How much air do I need? Fresh air do I need? It's number 4 because not everybody needs it. Not everybody needs humidity control if they're super adaptable or if they live in a place that's very, very forgiving, or if you don't need dilution air because your house isn't tight enough to. But if you're sensitive, then you might need dilution air, even though your house is leaky. And then the last one is pressure relief. And that has a lot to do with your one-way exhaust switch. Any high-performance home only has one, and it's the kitchen. And you've got to have it go outside. Anybody who tells you from a textbook for Passive House from 2009 that it's okay to have a recirculating exhaust hood in your kitchen and then a little tiny stupid ERV exhaust in your kitchen, I do not think that works. Yeah. And they know, because like now they're singing a totally different tune. And they're like, okay, we need makeup air because we got to have these kitchen exhausts go outside. Super important. So that's your 5 factors.
So you're just going back in your background. You actually wrote a book on home performance diagnostics, and you wrote that book because there was nothing like it beforehand.
Yeah, I wrote the book mostly for me because I got into this and I had a 90-page energy conservatory blower door manual. I had my little pamphlet that came with my what, this and that. And then I had like this, that manual and that manual. And I was like, I can't go into somebody's house with all these stupid books that are separate and they're made out of different stuff and they're different. And like, I'm standing there rifling through my manila folder to find the right, you know what I mean? It's like, what? So I wrote the book only so I could have something that would like quickly explain what the calculation is for this and that, so that I can do things in the field, know what I want to see, and then do the calculation to analyze the data that I got and actually spit out a result, instead of just saying like, I got to go to the office.
And it's called Home Performance Diagnostics. We sell it. You still sell it through?
I still sell it. Yeah.
On your website.
I'm just like, they get the same price whether they order it from, so buy it from Bill.
No. I want to build your credibility in case people don't know, who you are. Second thing,
ChatGPT knows who I am. I guess out there.
You also built a book because you needed it. You're frustrated. Nothing like that was available.
And by the way, can I just point out, people are like, what did you publish your book with? Who's your editor? Who's your publisher? We took all the photos of that book with my phone. I wrote that book in Microsoft Word. And then we self-publish through Lulu, and I order 30 copies at a time. And when Bill needs more, I order 30 copies from Lulu, and they ship them. And it's like, you don't need to wait. You don't need extra skills. The analysis paralysis. When you've got a good idea, just do the thing and like spend 15 minutes a day.
So your second point of credibility in my mind is you built a tiny house on wheels with your wife and your parents.
Yep.
Tell us about that.
So that was in their backyard. Why? If we came, the whole thing, and it has worked, by the way. This is what's really, I really like about where we're at now, is that like, this has worked. My clients, the plan has worked. My clients call me, normal people who found us on YouTube and watched a couple videos, and they know what ACH 50 they are looking for. I don't like cue them in. I'm not like, do you have a blower door ACH 50? I'm like, do you got a number for your air tightness? And they're like, yeah, I'm looking for like 1.5 or less. And I just love that so much. Like, pros don't know as much as most of the homeowners who watch our channel across the country. They are and I have clients in the Philippines who say the same thing. They're like, nobody around here knows anything about this. Why am I the only person? I'm like, dude, you could be in Manhattan and it's exactly the same thing. So we built the tiny house because if we came across the country to teach people about home performance or building science, whatever it is that you want to call it, and we're like, hey, do you want to come to a seminar about building science? The answer is total silence and people leave. Or the answer is no, thanks. If I say, do you want to come tour my tiny house on wheels in 2016, peak tiny house time? Yeah. So people would wait in line in the rain to see our tiny house. And we had in the rain, we had to turn people away because the power was out. But basically, people would come 5 days a week. We would go, we did this crowdsourcing thing. Grace, my bride, who is also good friends with Bill, is awesome. And she's the reason that the company exists. I'm the mule. She just points me in the right direction and says, go over here. So basically she was like, why don't we do this thing? Because this would be a great way for us to like get out, see the country. We were going to leave Chicago anyway. This would be like a way to kind of do a thing and make it an educational tour. Bill presented at the first ever Proof is Possible event in Tampa. That's when we stayed with my parents. And so we wanted this Proof is Possible tour. We stay for a week. Some company, some local home performance contractor sponsors it for $3,000. that was like, we were trying to do it on a dime. We built a tiny house. We'd bring a show, a circus. Everything that we did had their name on it. We would do radio interviews and blah, blah, blah. So we would have 5 days a week where we'd do an hour open house, and I do a carnival barker thing outside for the people who are lined up. Like, hey, have you guys ever, have you ever moved from one room to another inside your house and the temperature is different? In this house, that never happens because things like that. Then they would go inside 7 at a time with Grace, and I couldn't be inside because every time the door closes, did I tell you this?
No.
People, somebody, and it's adorable, but I hated it so much. People would be like, oh, you put your bed down there and you put the dining room table up there, because they've seen tiny houses before on TV. And they were like, oh, you put the bed up on the thing. And they were just like, that was so interesting to them. And I was just like, okay, well, we're going to stop talking about tiny houses because tiny houses are kind of dumb. And we're going to talk about what I want to talk about, which is building science. So anyway, that was a way to kind of sneak some broccoli into the milkshake. People want a milkshake, but then you got to put the veggies in it.
So, and then the tiny house was like 200 and something square feet.
Yep, 210. We lived in there for 5 years. Before this guy was not born. We had one baby who was 6 weeks old when we hit the road, and then we ended up having a second one in there by the time we finished this house.
In your circuit, your trip was how many thousands of miles?
13,000 miles. And what's interesting, the last season of our TV show, Home Diagnosis, was all about disasters like hurricanes and earthquakes. And a tiny house that's built for the road, which ours was, not many of them actually are, goes through an earthquake and a tornado at the same time on a regular basis, because that's what happens when you take it on the highway. So this house has to be super hardcore. It's built like a tank, and it's heavier than we thought it was going to be as a result.
But you also built it yourselves, except the frame, the trailer frame.
That's right. Yeah. You don't mess around with that.
No,
you gotta get that.
You need someone who's
and I think that's the thing. Like, we don't have cred. Somebody was like, oh, you're like a highly decorated building scientist. And I was like, I don't think anyone has ever decorated me except Bill pulling up my ChatGPT bio.
I think I adjusted the shoulders on your coat once.
That's right. Yeah. Oh, I used to have patches from BPI that I would wear. But no, I'm not. Like, you make your own cred when you're in this kind of field. Just like Eric did it his way. Bill did it his way. Yep. Bill has his names on patents, for tools and stuff like that. Like, I feel like that's the thing, is you got to get out there and like do something. So there's no master's degree for this. Right. In fact, most engineers think that what I am talking about is total BS.
Yeah. And then the third point of credibility is then you came back after your tour and you started building a home.
Yep.
That you designed while on the road?
Yeah, we took about 2 years designing it, because we bought this land, which is at 2.5 acres inside the perimeter in Atlanta, near the airport. And we got a creek and woods and all this stuff that we never would have dreamed of when we were in Chicago. And we wanted the house to be our forever home. And we wanted it to demonstrate all the concepts that we had been kind of like thinking of, and really prove out, true up some of these things that we were imagining were true. And it turns out that they're like it totally works. It actually works better than we thought it would, which is a great feeling. So yeah, we built this house with my mom and dad. It took 2 years, 2.5 years, really, if I'm being honest. And we did it with our own hands. And that was also fun, because you'll watch Matt Reisinger is a friend of mine, and I like him a lot, but you won't see him doing this stuff. Because he doesn't have time to. Largely, he's an employer. I don't have employees, and I want to know. Part of the reason I did this is because I'm a control freak, and I want to know what it takes to install a duct system. So I installed all my own ducts in this house. I installed my own makeup air system, my own ERVs and dehumidifier and things like that. And that cred, for those of you who are in the profession and want to be able to do this for other people, that is the marker that people want to consult with me on, is because oh, well, I want to talk to you because you actually have done this before. It's not like I read it in a book or I went to a presentation. And it's like airtight home, well-insulated home with an ERV and a blah, 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 all the things. You got to kind of do it yourself and then feel it.
People's shudder, I think, when they hear the word DIY, they worry about people doing it themselves.
Oh man, you know what I heard actually? I don't mean to interrupt you, but Orson Welles had this great quote about the amateur. The word amateur is like some bad word. It comes from, the root of it is amor, which is love. And please God, let everybody who is listening to this right now be an amateur at heart, because like,
Yeah.
if you don't love this, do not do this. It's not worth it. Right? It's like too much work. if you
Yeah,
don't love it.
absolutely. So I'm going to just back up to that. Do it yourself. But if you're in the field, consider do it for yourself, is what you're saying. Do it for yourself first.
I mean, I think that if I have, and I do on a weekly basis, a disagreement / argument / somebody hates my guts and wants to pick a fight with me kind of thing, who is a professional, I will always win. It used to happen because I had more data than I did when I was a beginner and I didn't actually know anything. Like, I knew less in my first year than Eric knew in his first year when he was an HVAC contractor, because he actually was out there like doing this stuff. I was just like, I see reports from my first year in business in 2008. I'm just like, God, what an idiot I was. I didn't know anything. But
I do just want to throw in here, you said this was a lot of BS, and you're right. It is a lot of BS. It's a lot of building science.
Good one. I like that.
Okay.
But seriously though, engineers are not our friends. And
man, you're raining on Bill's parade over here.
It's okay. I'm
Bill
a
knows.
recovering engineer.
Bill knows because he is an engineer. Bill, can you please back me up on that?
Sure. Yeah. I think, again, do it for yourself. Understand it. Work with someone, and you'll be surprised at things that you think you know but don't really know.
Yeah. And knowing it's like credit cards. I like to make the point like this. Like, we were told when we were in high school, credit cards are bad for you. And you're like, yeah, I know, I get it. But then you don't actually get it until you do it. And you're like, oh, I get it now. It's that feeling. It's exactly the same as that, where you're like, oh, what an ERV feels like and what an HRV feels like. You can't know unless you literally live with it for weeks and months through seasons. And you're like, oh, like that's what it is. I didn't feel radiant temperatures until I lived in a tiny house and every surface was less than 5 feet away from my face. And then I was like, oh my God, like I feel what this is. So yeah, becoming more aware is good, but you also got to like put yourself in situations that are uncomfortable.
Yeah. And I've chewed up all the time here, not all the time, but part of the time. And Eric, I want to let you ask Corbett some questions, get some conversation going here.
Well, so I want to go back to these 5 factors of ventilation, and I want to dig into a little bit about, kind of each one here.
Great.
Let's talk about them a little bit more in depth. I felt like that was a little bit high level on some of them, and let's
isn't it funny how long that took to get just the high level? It's ridiculous.
Well, yeah, I mean it is, and let's put it this way. When I got into HVAC, a friend of mine's dad was in the trade, and he's like, "Oh, you're just going to need some gauges, a couple screwdrivers, maybe a meter. You're good to go." When I retired, when I left the active field and came out of my truck, I owned more than $25,000 worth of test equipment just for HVAC, and I hadn't really dove into building science yet. And by the time we start talking about tools to test duct leakage, tools to test building leakage, all the other stuff that involves, it's not inexpensive to have really good tools to do this stuff. But you also have to know how to use them, and you have to know how to pull that data back out of them and then apply it. And it's not uncomplicated. Let's put it that way.
Oh yeah. And you don't trust yourself after you've been doing it for a long time. Like I had, as somebody who wrote a book about testing, I've had situations where I go in and I test a fan and my tool says like not what I expect to see. And I'm like, oh, this thing's broken. And I throw it in, and then I grab another one and I do it, and it's like, this one's broken too. What is this? And then I grab it there and it's like, dude, the fan is running backwards. Like you've got to get it through your head. So anyway, I step into situations and I have weird expectations. So the 5 factors. So we can start with circulation. The ceiling fan thing is important because you got to wash surfaces. Like if you think about a teepee has circulation. There's a chimney at the top. There's a hole at the very top of the teepee. And then at the bottom, they've got a little gap at the bottom and air comes in. So air is moving in a certain pattern. If we're talking about patterns, I like central returns, for example, because I know where the air is going to go. The path the air is going to take is I'm going to pressurize just like you would in a hospital. Every room is either pressurized or depressurized or neutral. Like the lobby would be neutral. The operating room is pressurized because you don't want any air from the hospital rooms going into the operating room. A room where you're going to put somebody who's got Ebola is going to be depressurized because you don't want any air from that room going anywhere else. So same thing with a home. Bathrooms depressurized, bedrooms pressurized. Use undercuts on doors to pass air from one place to another.
To the
In a
return.
high-performance home, that can really work because most bedrooms are going to get less than 75 CFM, and that's your limit on the undercut on the door.
Well, and I mean, I came from a Midwestern, very metal duct. We ducted everything. Like we wanted ducted returns everywhere. That was
and low and high.
No, we didn't do that, but we wanted them in each room so that people could close doors. And that was the logic. And I've evolved on that a lot. And one of the big drivers of that evolving was a comment Russ King made one time. And I think Bill and I were talking to him maybe on another live stream or on a podcast. And he mentioned that every room you put a return duct into doesn't get a chance to vote at the thermostat.
And
I thought, wait a minute, that was a brilliant insight to me. And it changes the way that I thought about how the house and the duct work, which is the house, like that's the biggest piece of duct work. It's a low pressure, low velocity duct, but we still have to control velocities in there. And you mentioned that slow movement of air in things. And when I look at systems, like I want to design my duct systems and especially use that manual S from ACA to put that air onto the surfaces that are transferring heat between outdoors and my room. You know, that's kind of my goal with design, because I know that I need to overcome that. And if I overcome that, then that will circulate enough air in the rest of the room.
Yeah. And what's interesting, so I think I find people being a little unreasonable with their expectations of their HVAC system. So they'll come to you nowadays, like there's all kinds of new things where you'll see trends. If you see enough building plans, you'll be like, oh, wow, they're doing this now for some reason. Like, for example, now it's like these master closets that open onto the master bathroom, not onto the master bedroom. This is a new thing that's like, oh, weird. Now we've got this new problem of this humidity migrating into this big place where you store a lot of soft stuff. We don't want that. So, so if you're thinking about that with new construction, high performance, where you're insulating extra, you might be using exterior insulation. You might be doing air tightness. It turns out that if you're going to use ceiling fans to mix, you could basically introduce that air almost anywhere in the room and it'll get grabbed by the ceiling fan and taken around. I still, like you, learned to, when you were working on standard construction homes, put the register as far from the door as possible, because I want that register, which is carrying not just heating and cooling, but also now filtered air, humidity controlled air, and dilution air, because I like to plug all that stuff into it at the same time. I like to have it spend as much time as possible in the room before it leaves under the door. So it's like kind of the same principle, but yeah, it's same outcome, different reason, I think, these days.
Yeah. Yeah. I mean, there's a lot of reasons to do different stuff. Hey, Ben Walker, good to see you on here.
Oh, yeah.
Ben Walker.
Yeah.
Retrotech. He's in Dublin.
Apparently
let's talk about blower doors again.
Apparently in Dublin.
Nice.
Good to see you, Ben. So, I mean, and to that, circulation in a room and circulation in that room is really important. And a lot of times as HVAC people, we think of circulation as in the ducts. We don't think of circulation as actually in the room itself. We're just thinking of that equipment, maybe the ductwork a lot of times.
Sure.
So I think that's an important distinction to make. And we have to pay attention to that when we're designing it. And my life has mostly been around retrofits. I've done very, very few new builds. I'm much more of a retrofit person. Like, we've got all of this housing stock out here that we need to keep going. Like, we can't replace all of that. We don't have the infrastructure. We barely have the infrastructure to build the new houses we need, much less replace all of these existing homes. And I love going in and really digging in and making that existing house, making the adjustments that I need to keep those bones alive.
Yeah. Please keep doing it. We need more people like you that are willing to do that. I tend to work with people who are like, have had enough with trying to do that because it's exhausting, right? You know,
It can be. It takes a very different mindset to go in and do that for sure.
So anyway, I think that the where you put the ductwork and all that stuff then goes into that circulation piece.
Mhm.
And so
Absolutely.
that's then, yeah. So we got to have this air moving. And by the way, this is where, like I've made, this is a tangent, but it makes sense. I've been making some spray foam videos lately. Not because I'm anti-spray foam. Spray foam is a building material, and it deserves a place in the whole arsenal of building materials that we've got. But it's not everything. And I think that who I'm arguing with when I make a video about it is the marketing departments who are like lying to people about this stuff. And so that's really when I do that. And likewise, when you listen to HVAC manufacturers about circulation, HVAC, we need them. I love them. But they're going to try and sell you mini splits. And mini splits do not mix air between rooms. And they might not even mix air within a room very well. And they don't. So circulation, number one, I'm not getting it. Number two, they don't have good filters. Number three, they don't do a good job dehumidifying. Number three, they also don't have a way to a pathway for you to deliver humidification anywhere. Number four, they don't have a way for you to plug in an ERV. Right. And so like they solve one thing, which is the heating and the AC, which we didn't have a problem to begin with, which is why we built this slide. Let me see if I can show this real quick.
You want that slide that's down there?
Yeah.
This one?
You got it? Yeah.
There you go.
So this is, I have this happen. This is like the telling the story thing where I'll be like, look, man, we got an hour to do this. I did this today, actually. The guy said, we're planning on using radiant for heating, and then we were going to sprinkle mini splits around. And I'm like, cool. We could do this the hard way, which is we talk for an hour and we do it your way. And then at the end you go, well, that's not going to work. Or I could just tell you right now, the ending of the story, which is a bunch of mini splits and some radiant doesn't really work because you're not going to get this thing. If you want to be on a budget and you want to do this elegantly, you build one central interstate highway between all the rooms, which is your duct system. And then you plug an air handler in the middle that's a big fan, and then you plug a bunch of little fans onto it to deliver things like dilution air, dehumidification, humidification, things like that. But the room that I'm in, as an example, that my little boy is sleeping in, has a mini split, a ductless mini split on the wall up there. It's a Mitsubishi. It's beautiful. It's super quiet and like all the things that we love. But it doesn't mean I get away without ductwork. I have 3 duct systems in this crawl space underneath.
Nice, yeah.
One of them is for filtration, one of them is for dehumidification, and one of them is for the ERV. And like, so I have 3 times more, 300% as much ductwork as you would if you did it this way by doing a ductless heating and cooling. Like, it doesn't solve things. It solves one thing and then creates a whole bunch of other issues that you need to decentralize at that point.
Yeah, there's definitely, I used to be a really, really big fan of mini splits. And the more I've learned about them as I've gone along, there's some challenges. Definitely.
Maintenance is another one, right?
Maintenance is a big one. They need a lot of maintenance.
And people don't know it until 8 years in, and then they're like, what is that smell that's been in this house for 7 years?
Depends on what kind of part of the country you're in. Some of them it's 1 to 2 years in.
Yeah, right.
But yeah, they need a lot of maintenance. The filtration is definitely a challenge. One of the challenges I have had with them is they don't do a good job of conditioning a ceiling because their discharge is on the bottom and their intake is on the top. So they're not doing a great job of really pulling that air across the ceiling or putting the really super conditioned air that's coming out of the discharge across that ceiling. So I've playing around with one here in my office a little bit. I've noticed that the walls are pretty good temperature wise, but looking at that ceiling, it's a little bit warmer. Yeah. And I don't have direct sun coming on the ceiling because of how this is set up. It's because I've got an office inside another building and underneath a roof. So it's not like I'm direct sun and I've got the same temperature on 2 of the walls that I do on the ceiling as well.
Yeah.
And essentially the same insulation in them. So
He calls it his tiny office.
yeah, it's my tiny office.
I have one of those.
Do you want this up here anymore? You done with that one?
No. So what I just point out about this, and I've shown this on HVAC School podcasts, and I've shown this around the country. I would love it if anybody can find anything wrong with this, because I am not the kind of person who would believe that there is one answer for everyone. And yet I'm pretty sure that I have come to the belief that like everybody should basically be doing this, which I hate.
Yeah.
Also, these 5 factors I've presented in front of like Positive Energy, who does all of Matt Reisinger's HVAC designs. I sat down with them for 2 hours and I was like, let's talk about this, because I feel like sometimes I'm off in this weird niche where I'm not talking to anybody except my clients, and I'm like just vomiting up this information all day long, and I've kind of painted myself into this corner. Are we agreeing about this? And they basically are like, yeah, we do exactly the same thing. We're recommending all the same ERV, makeup, air, da 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 da. They do it way more detailed than I do, which is why they, are at the level that they're at.
Right.
But yeah, I think that this is where the engineers really haven't been working in this. And that's why they're not going to agree about this use. So if you go get a mechanical engineer to, sign off on a design from somebody like me who's thinking about it this way, they're going to be like, what is this? I don't know. You can't do this. Yeah.
Well, and looking at this drawing right here, this looks like this looks much more like a heavy commercial building, something that they're going to put a lot of work into that because they know that there's going to need all this stuff. And in residential world, we've kind of gone down that road of let's go cheap.
Yep.
Because that's what a lot of the homeowners, they don't know any better. But when you get into more of a commercial space, they tend to understand air pressures a little bit more. They want things balanced because you've got a much larger building and it can really affect things a lot more.
Yep.
Things like stack effect, holding doors open, or in buildings where you have kitchens and a lot of exhaust fans and things like that. It can make a big difference on smaller openings.
Yeah.
Like that.
And the prime mover, by the way, if you think about it as like a series of dominoes, the one domino that falls first that is going to make all of this be necessary is air tightness, which you want. If you want no bugs, and in my house, we've never had a pest control company spray, and we never will, because there is no way for bugs to get in here. But Bill, do you have bugs? You had a modular.
Yeah, we do. We have a couple bugs. We have stink bugs. You know, if you know what those are, lovely creatures.
Love them. Yeah, totally. But they don't stink unless you squash them.
Right.
They have great personalities.
They're ready to stink bugs.
Like right.
Ready to eat meals. Yeah.
So quiet though, humidity control, temperature control. It's so many things. But when you tip that thing over, all of this, you'll get to the point where you got to have ventilation. And as soon as you're airtight enough, you got to have balanced ventilation. And once you have an ERV, an HRV would be way worse, twice as worse as this. An ERV at least buffers a little bit of the humidity and the temperature. But it is the reason that you need the dehumidifier. You need the humidifier at that point. Because the ERV is running, you're going to have these other problems. And you can't do without it because now we can't use bath fans, And then you get people who are like, but I got to have my wood burning fireplace or 2 wood burning fireplaces. And I was like, all right, as long as you're okay with it, when you burn one, the other one becomes the makeup air pathway and you're going to smell smoke in your house all the time. We spend all this time and money trying to make this place healthy. And it's going to this one thing is going to be a problem.
I mean, or you can duct in just a natural makeup air with a damper switch on it right next to the fireplace.
Interestingly, this is a really important point, I think, to make. Airflow is a barrier with a pressure differential across it and a hole, right? That is what airflow is. You have to have all 3 of those things. When you have a passive makeup air system, which is you have a suction on the house and then you open a hole to outside and you let air come inside to replace it, the house must stay slightly unbalanced. Because if you were to actually fully equalize the pressure, then no air flows.
Yeah.
Yep. So it can't work, right? So you can go about to 2 pascals. And the problem with that 2 Pascal depressurization constant is that is the level where I have seen chimneys become the makeup air pathway. So if your house goes to 2 Pascals, you're using the chimney as a makeup air pathway. You're going to smell the chimney. If your house stays at 2 Pascals, that's like, it's not better than us just not, see what I'm saying? Like making up that air that way is just not going to work with a fireplace system. So you got to use active makeup air, which is a $2,500 system. And now it's like, what are we doing? And before you say, hey, let's do a direct vent fireplace, by the way, go to a fireplace showroom and walk around the back side of the display and look at what the back of a direct vent fireplace looks like and be like, how am I going to air seal this exactly? And that would raise the right questions, I think.
Yeah. So I want to go around this drawing real quick then and talk about some of the different things you've got on here. So, and what I'm looking at this, let's start on the left side there. We obviously understand the trunk, the branches, the returns, the supplies, but let's start on the return side. You've got an insulated makeup air coming in from outside with a mechanical damper and a power sensing switch on the kitchen exhaust. So that is really specifically for your kitchen exhaust.
Yeah, if you do it that way, and I don't advise that people do it this way, and there's all that's why we've got 800 or 1,000 videos on our YouTube channel, is because I'll get somebody. And when we first tuned in tonight, I was like, I have to respond to a troll because people will come on and watch one video and be like, da 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 da, and I was like, dude, go watch like 100 more videos, please, because you're not getting the whole picture because it's too big to talk about. This makeup air, if you're going to kick a kitchen exhaust hood on way over here on the right hand side of the frame, and then you're going to put your makeup air into the return of your duct system, the makeup air is going to come out the first place it possibly can, which could be your bedroom on the other side of the house. And then it'll snake its way through your bedroom, down the hallway, and into the kitchen. And then you'll walk into your bedroom an hour after you made dinner and be like, why does it feel so weird in here? And it's because we just made this really long, circuitous pathway for this makeup air to take. So you got to think about those kinds of things. Generally, I'm recommending that people put the makeup air as close as possible to the exhaust point, because then the connection of air between those two outlets is going to be replaced with outside air. So that'll become like a river of just purely outside air. And you just don't want that very long because it'll wander around your house and do weird things.
Unless you have that air handler unit running, correct? Because if
you do want that air handler unit running for a lot of this stuff to work properly. But yeah, even in that case, it'll still kind of like come out the wrong way. And if you're in Bill's neck of the woods, where do you live, Eric?
Indianapolis.
Okay, so not that far. So it's like, you're going to get a 20-degree day and it's going to dry out and weird out the temperatures in the house. And also it's going to weird out the materials in your duct system. And by the way, you got to put that thing at least 10 feet upstream from the air handler, because the air handler the heat exchanger might crack if you don't, kind of thing. They have
throwing cold water on it. Yeah. Cold air on it.
Yeah. You got to have good mixing if you have a gas furnace versus
I like the way you described river of air moving around when you get these pressure imbalances. That's a very strong visual. If contractors are trying to figure out, how do I explain to someone that they need this, or if they believe in it first, if they've done the DIFY, they'd be able to explain this and use some of this terminology you're using.
That I feel like if we were trying to explain this 1,000 years ago, it'd be a lot easier, because 1,000 years ago we had smoke in the air everywhere. And people understood that we live in a fluid. Now, it's so clean around here that you don't even. So yeah, becoming aware of that Tai Chi of the movement, the flow, and everything. That's really what this is all about.
Very cool.
So then we've got just general, what I'm going to say is outdoor air. A lot of people will refer to this as fresh air, because we're assuming that outdoor air is fresher than indoor air. And sometimes that's a good assumption. Sometimes it's not, as we've learned through more and more testing. Sometimes outdoor air can be worse than indoor air at times.
Not a lot of times, but yes, there are definitely times. And that's particularly why this purple filter box is very important. If you put a MERV 16 filter on there, and it is 100% possible to get a MERV 16 filter that does not choke your airflow. So make sure everybody get April Air 2516, $240, comes with a MERV 16 loaded into it, you're looking at less than 0.1 inch of water column if you use it on an appropriate system. So that will strip out 95% of big and small particles in a single pass. So air comes in, bam, you grab almost everything out of it right before it hits the air handler. So that can work. And you definitely, like Eric said, put a filter in line because that's important.
Yeah, what I'm doing on my house now is I'm actually doing a MERV 8, a large MERV 8 on the outdoor air intake before it gets to anything, so that I'm keeping all that duct work. I'm keeping everything clean from the I guess it's more of a larger particulate filter. And then, I'll use a MERV 16.
Mosquitoes and daddy long legs and all the things. Yeah.
Right. Because that's all going to come in there. And I don't want that building up. I'm going to put that really close to my air intake because I want that to stop there.
Yep.
I don't want that building up in my ductwork. I don't want it getting into the return air ductwork because then they can wander around in there and do all kinds of stuff.
Yep.
I want that stopped good tight filter with no bypass.
Which, by the way, that's a really important point, Eric. The next thing, and I'm pointing out to the other people, I know that you know this is a good point. ERV, when it comes into the return, this is an either or choice there. If you're going to do an ERV and put it in the return, which is great because then you get double filtration on it, you've got to keep your air handler locked on. Because like Eric said, it's going to be allowed to wander around wherever it wants. And if it can make a choice to turn left or to turn right, it doesn't want to go through a MERV 16 filter and through a heat exchanger and through the supply ductwork and past all the blah, blah, blah and the dampers. It's just going to turn left and come out through your return, your central return.
Yeah.
And then you've got this giant pool of fresh air around your central return and none of it in the bedrooms with the door closed all night long. And that, by the way, goes for zoning too. Just be careful with zoning because that's if your zone's closed for a significant amount of time, you'll have that same thing happen where certain rooms just get dead because they're not getting heating, cooling, but also filtration, dilution air, and humidity control.
Yeah, for sure. Because zone systems can do weird things. I've done again with my first employer. We did a ton of zone systems. That was pretty neat stuff, but learned a lot of things there. And successfully you can do a lot of stuff. Now that kind of takes care of a lot of our intake air, supply air. What about this dehumidifier up here? And I see you've got an outdoor air intake. Now that would be not necessarily in place of the ERV, because the ERV is your balanced ventilation.
Yeah, that's a thing. Scott True, if you know who Scott True is, he's a client of mine in Texas. He's trying to build, or was before Matt Reisinger made him famous, trying to build affordable high-performance homes. And now he just is like too busy to answer the phone for most people, unfortunately. He's a great resource. But he was trying to figure out a way in his journey, because he was doing like step. He'd add some things as he built. And he was trying to figure out a way to get makeup air for vented dryer, because some of his clients wanted vented dryers. At this point, he basically is like, no, you have to have a heat pump. Sorry. If you don't want that, you can go buy a house from somebody else. But this is with most vented dehumidifiers, like what we're talking about is a ventilating dehumidifier, Santa Fe Ultra series.
Yeah.
April Air has this 80, I can't remember what it's called, but it's like the 8100 or something like that, manifold that you can put onto their thing. It does kind of the same thing. It's not exactly the same thing. It's got a collar that you can use to get outdoor air in. And if you wanted to, you could bring in what is approximately 75 CFM. A dryer is rated for about 150. So you're bringing in about half. But if you do the calculation through RedCalc, which is a free online calculator through the Department of Energy now that they bought it, thank goodness.
Did they?
Yeah. So it's going to be good, because Rick Carg needed to retire eventually. So yeah, he finally did. So if you use that, number one, it's 75 CFM. It's not that much. Number two, if you were to try and use that, like Eric was saying, instead of the ERV, which some people in like Florida or in humid places are trying to they're so worried about humidity that they want to come straight in through a dehumidifier and just take as much as they can out of it. 75 CFM is not that much. Like, Bill, what's the ERV rate on your house?
It'll go up to 300.
What do you keep it at most of the time?
It runs on a sensor, a CO2 sensor.
Interesting.
Maybe 150, but just as needed.
Yeah.
So it's not always on.
Mine's 130, 135, I think.
Yeah.
So like neither of those is in the range of 75 CFM, like
Right.
what we're looking at here. If you wanted to get 125, you could get that 205, the biggest $5,000 dehumidifier that they make.
Yeah.
That'll give you 125 CFM. But you're looking at basically a 25%, 75% ratio on that outdoor indoor collar. And I just don't think it works. So just if in case anybody's like going down that rabbit hole, I just want to put that in your ear that like I don't think ventilating dehumidifiers, like no offense, Santa Fe, but I don't think that they fit the bill for what we need these things to do. Oh, and it goes, by the way, into the supply because that's what it should do. And any manual that you read from an older piece of equipment will say, don't put it in the supply, put it in the return. But when you do that, you're robbing the evaporator coil from being able to dry as well. So you have only one machine drying instead of two.
Okay.
Yeah. Yeah. And that came out of a bunch of research that I believe Andy Osk did and Rick Sims did down in Florida. I remember Rick and Andy talking about that one year, and they did a lot of testing on that, and they figured out that supply introduction of that dehumidified air was by far the best dehumidification you could get in the house.
Yeah.
So
while we're on the topic, by the way, about research, Attila Novoselic, who's one of our researchers that we feature a lot on our channel, found that the supply plenum just past the air handler is dripping wet for about 7 minutes after the cooling cycle has stopped. When it's bleeding off the temperature of the coil, it's like re-evaporating, and the dew point gets reached like super fast because it's very sensitive in there. So anyway, that kind of thing. And then he found
humidification regain.
Yeah.
It's the air that was in there, right, cooled down, super high humidity. Now you have radiant cooling coming off that coil, and it's dropping the temperature of the duct because the duct had air moving through it. Mm-hmm. Now you're dropping the temperature of the duct actually down to the temperature of what that coil was, which of course was colder than the air. And the air coming out of a cooling coil is 90-ish, 95-ish% RH. So yeah, makes perfect sense. And that's why we see a lot of bacterial growth in that duct immediately after the coil.
Yeah. So because it's not part of the 5 factors, but like putting a little hatch into your supply plenum so that you can just like inspect and clean if you need to, kind of thing. Like those are like, who would know that? And that's why you got to watch literally hundreds of hours of videos to understand, and like crazily, there are people out there who are doing that. I have like a huge number of my clients will have watched hundreds of hours of YouTube videos, and then they will come to it with what is essentially a bachelor's degree in building science compared to most professionals, 0 hours of continuing education on it. You know what I mean? I had this woman today who was like killing me. She was like, she was like, yeah, I've just become a master HVAC installer, I guess, because I had to, because nobody around here knew what I was talking about. And it's like, I could have listened to her all day long talking about how like she did this and that. And she took off the wall so that she could get at the coil and the blower and make sure to clean those every year and da-da-da. And I'm like, I love you so much. But yeah, there are a lot of people out there who are learning a ton.
So the one other thing I want to talk about here then is this humidifier. And there's a lot of environments that probably don't necessarily need a humidifier all the time, but there's quite a few that do. Even I was kind of surprised to learn that even a lot of tighter houses, being from a climate that's cold, we put a lot of humidifiers in over the years because hey, we got loose houses, lower humidity outdoor air gets introduced to the house. It's going to dry that house down quite a bit. But I was interested to learn that even the tighter houses, when you have that makeup air coming in, still going to dry it out, not quite as fast.
Yeah, but it eventually will. That's, by the way, one of the reasons why mini splits, you got a house with 10 rooms in it, and you're thinking 3 mini splits on the walls. It's not going to work, because at that point, what you're then going to do with your ventilation is to get a Zender, because people are like, oh, mini splits and a Zender. That's going to solve all my issues, because I've heard that they're both great. And like, that's where you just can't trust people. So they're going to put these 3 mini split heads in, and they're going to Zender each one of the bedrooms. And the bedroom is going to get loaded and loaded and loaded with humidity and with outdoor air temperature. And it's not being served by a conditioning device. And it's not being served by a dehumidifier either. And then it's like, so it drifts and drifts and drifts further away. And what we basically end up with is a house that feels exactly like 1890s house, but it's built in 2024 instead. You know what I mean? That kind of thing. So anyway, steam humidifier is a perfect example of a piece of equipment that you should know how big it needs to be if you're going to need it. There are calculations for this. I do stuff like this on the YouTube channel all the time. And then leave a place for it, mark where you would inject the thing, and then know that like you have the option to do it later, because that's all you want, is you want to know what the options and the consequences are.
And make sure you're going to maintain that, because that's something else that has to be maintained well.
Oh,
you're not going to have good luck with that steam humidifier over time.
The HVAC researchers that we've had on the channel a lot lately, Jeffrey Siegel from Toronto, he's amazing. If you haven't heard him talk, he's incredible. But he is like a huge proponent for humidity control. And he has decided that it's not worth the risk and the maintenance on his home to humidify. So he's just like, I'm just going to deal with the dry air because it's just not worth it. In my home, I drift south of 30% sometimes in Atlanta in the wintertime. And I'm like, it's not worth it. I'm not doing it either, because I just don't want that risk of the mold and all the stuff on the inside of your ductwork past your filter. It's like, you don't want it there.
Well,
I think we're wrapping up here.
Yeah.
Awesome. This guy, he's had enough.
We've put him to sleep. Clearly, we were a riveting presentation tonight.
I think someone was betting on how soon he would fall asleep.
There may have been that.
Yeah, melatonin was involved in this story. Yes. This is a drugged child.
Corbett and little one there, thanks for coming on tonight. We really appreciate it. I had a great time.
More little.
Here's another one.
Hi.
Crying.
Okay. All right.
Yeah, time to go now.
See, the chaos all waits till the end.
She thought that you would be out at exactly 8:30.
You guys, why are you keeping me on this?
Why have you taught the children how to tell time and be so precise?
It's 8:32.
This
Well,
is going to be a good one.
I guess this means we got to end.
Yeah.
So
Awesome. It was great to talk with you guys. Thank you very much for the invite.
Good night.
thanks, Corbett, and good night, everybody. Thanks for
Good night,
joining us
everybody.
tonight.
Thanks,
Good night,
guys.
Corbett's kids. Bye.